This demonstration or animation is going to show you how the moon affects the tides along with the sun and how we get different types of tides and tidal ranges. Right now, you'll see that the Earth, the moon, and the sun are all in a straight line. Just to give you guys a little tour of what we're looking at, we're looking at the top, so this is the North Pole. This red dot would represent one spot on the Earth, so we can watch that move around, so that spot's not going to move on the surface of the Earth. As the Earth moves, we'll see that dot move. The moon, always 50%, is always lit because the sun's always shining on half of it. However, what we see is only going to be the side facing the Earth. So if we cut off this back half, we would see the moon completely shaded in. We would call that moon a new moon, so it would be just sort of a dark circle in the sky. Sometimes you can see a little bit of it, sometimes you can't. This is what we call a spring tide right now because the Earth, the moon, and the sun are all in a straight line. If we take a look at these two blue lines, this dark blue line represents the solar tidal bulge, or the solar high tide. In other words, the sun has gravity, therefore the sun's pulling on the water, creating this high tide. This light blue area is the lunar tidal bulges, or the lunar high tide. This is caused by the moon's gravity pulling on the water. The side over here is caused by the spinning of the Earth. Just like if I had a bucket of water and I started spinning the bucket, the water is going to get pushed to the outside of that bucket. So this is the second high tide caused by the centrifugal force of the Earth's spin. Where the blue is really close to the Earth, these two spots represent our low tide. So right now, we'll say this is a person standing on the beach. They're experiencing a high tide right now. So again, this is called a spring tide because the moon's pulling on the water in this direction and the sun's pulling on the water in this direction. So these two gravitational pulls are acting together, which is going to pull on the water extra hard, creating a higher high tide. So they add together. That's a constructive wave. If you remember from our last unit, constructive and destructive waves, this would be considered a constructive wave. Therefore, our high tides are going to be really high, and our low tides are going to be really low, and that's going to give us a high tidal region, or high tidal range. Okay, so we're going to map the tidal range, and we're going to hit play. Notice the red dots moving in and out of those high tides and low tide ranges. Okay, once we get to this location, notice it took 7 days for the moon to revolve to this point. So it took about a week to go from what we call the new moon phase when the moon was over here to what we call the first quarter. So from Earth, we would see that. We call it the first quarter moon. We call it a quarter because if we take the circle, and remember, we can't see the back half of the moon, so if we cut that in half and eliminate the back half that we can't see, we're left with 1/4 of that circle. So we can only see 1/4 of the moon. When the moon, the Earth, and the sun create a 90-degree angle, or a right angle, we call that a neap tide. This is considered a destructive interference wave because the sun's still pulling on it in this direction, the moon's still pulling on it in this direction. Okay, so where's the high tide? Remember, we always have two high tides, but the one is always next to the moon or in front of the moon. The moon has a stronger pull on the water because it's closer to the Earth. There's two factors that affect gravity. One's mass, the other is distance. So the sun has a lot more mass, therefore more gravity, but it's also a lot farther away. So since the moon's much closer, it's going to exert about twice as much gravitational pull on the water than the sun. So our high tide is here. Although some of our water did get pulled over here, so that's going to make our low tides a little higher than normal, and our high tides are going to be a little bit lower than normal because some of that water got pulled in this direction. If we take a look at our tidal map down here, or graph, This was our spring tide. See how high our tidal range was? This was our high tide, this was our low tide. During our neap tides, we still have high and low tides, but notice our range is much smaller. Our high tides aren't as high, and our low tides are not as low. Okay, now let's move forward. Can you guess how many days it'll take to get to the next phase? Okay, took about another 7 days to get from here to here, about a quarter of it, so another week. Notice our moon, the earth, and the sun all create a straight line again. Because they create a straight line, that would be a spring tide. It's another constructive wave. And here we would have a full moon. So again, if we eliminate that back half, the part that we can see is completely illuminated. So that is a full moon. So we would see a full circle in the sky. Okay, notice how our tidal range is getting smaller again. Now we're at our third quarter moon. So if we look at the night sky, now if you look, hold your hands up to the sky, you'll see the moon will fit your left hand now and not your right hand. So that's one way you can tell the difference between a first quarter and a third quarter moon. Notice the moon, the earth, and the sun make a 90-degree angle again. Therefore, the water's getting pulled in two different directions. Still, the high tide's going to be next to the moon, and our centrifugal high tide's going to be opposite the moon. Notice our tidal range is starting to increase. And now we're back to a spring tide because the earth, the moon, and the sun, again, are all in a straight line. All the gravity is going to pull in the water in the same direction. And now our cycle starts over again.